We have problems dealing with addition and subtraction of algebraic fractions. I believe I gave you problems 11 through 33, the odd, on page 85. Are there any there yet? Yes, Jan.
No, 19.
Number 19. Okay, number 19. We want to add these two fractions. They have unlike denominators. So we have to find the LCD. The first thing we have to make sure of is that each one of our denominators are prime factors. They are both prime. So we're ready to find the LCD. What would the LCD be, Jim?
3x plus 2, quantity 3x plus 2 times quantity x minus 1.
Very good. That is the LCD. This is what we want to make each one of our denominators, Jim. Here's our first denominator. This is what we want it to be. What are we going to have to multiply this first denominator by in order to make it the same as our LCD?
X minus 1.
X minus 1. Therefore, we multiply the top by x minus 1 also. We're multiplying both numerator and denominator by x minus 1. Our second fraction. Again, we want the LCD to be the second denominator. What are we going to have to multiply the second denominator by in order to make it the same as our LCD?
3x plus 2.
Therefore, we multiply the top by 3x plus 2. And there we have made it a single fraction. All we have to do is clean up that numerator. By that I mean clear parentheses, combine like terms, factor if possible. So if I clear parentheses, I have ax minus a minus 3ax minus 2a. Combining like terms, I have negative 2ax minus 3a. Okay, Jim? Now what can I do with this? What can we do? Factor out of a. I'm going to factor out of negative a. So it gives me negative a times the quantity, 2x plus 3. I now put that over the LCD. If something goes out, great. If nothing goes out, that's great. Nothing goes out. The nice part about factoring everything, if something does divide out, you'll see it. Okay, number 19. I'm sure they wrote the answer probably as negative 2ax. They probably didn't factor a negative a out.
Do you need to do that all the time?
Yeah, I always factor,
Okay.
just for safety reasons. Okay? Any other ones there? 33. 33 was a real nice problem, real bruiser. We have x over 1 plus 1 over x minus 1 minus 1 over x minus 1 times x minus 1. What we want to do now is pick up an LCD. Notice each of our denominators in factor form. Remember that this LCD, each of our denominators has to divide evenly into. The hardest part of this problem is probably finding the LCD. What would be the LCD for this problem, Tim? X minus 1? Does every term, he says x minus 1, does every term divide into that? Well, this does. The second does. Does this divide evenly into that? No. What do we need for an LCD then? X minus 1, written twice. Remember, Tim, I tried to emphasize this the other day. Once you get the denominators in factor form, there's only one LCD for this problem. Only one. No matter which end you start. If you started here, taking everything from this one, you'd have x minus 1, x minus 1. Then you'd have been finished. But going the other way, we have 1. You pick up an x minus 1. This says we better have 2 of them, so we need another one. And as I said, this was the hardest part of this problem. Once we have the LCD, our job is to make each one of the denominators the same as the LCD. That means this first denominator I'm going to have to multiply by x minus 1 times x minus 1. I multiply both numerator and denominator by that. We now move to the second fraction. What I want it to be is x minus 1 times x minus 1. Well, I only have 1. I have to multiply both numerator and denominator by x minus 1. Third denominator. Well, it's already the same as our LCD. I don't have to do anything with that denominator. I do nothing with the numerator. And there we have made it a single fraction. Now the job, Tim, is just to clean up the numerator. I told you, when you have a problem like this first term in the numerator, it's best to take care of the FOIL first. You don't have to, but it's easiest. If I FOIL this, I have x squared minus 2x plus 1. Now we're going to have to multiply through by x. We get x cubed minus 2x squared plus x minus 1 minus 1. Combining like terms, we have x to the third. We have a negative 2x squared. We have a positive 2x. We have a negative 2. And this is all over x minus 1, x minus 1. And that should be the answer in the back of the book. It's correct. Okay, let's go on. Let's finish up this unit. And let's go back to arithmetic. On the board, I have what's called a mixed number, 6 2/3. An arithmetic mixed number. A mixed number is made up of a whole number and a fraction. Now, in math, we cannot play with mixed numbers. So what we have to do is change this mixed number to its equivalent fraction. We want to change 6 2/3 to its equivalent fraction. What would be the equivalent fraction for 6 and 20 over 3? Mike says 20 divided over 3. Mike, how did you get that?
Multiplied the 6 by the 3 by the denominator and added the 2.
Okay.
And cut 20 and then keep the denominator.
Okay, what Mike said he did is he multiplied 3 times 6, the denominator times the whole number, added the numerator, got 20, and put it over the denominator, which is 3. Okay, Mike? That's what you did? Why'd you do that? What gave you the right to do that?
Well, you have to change it into a fraction.
Yeah, but what gave you the right to do what you did? That's what I'd like to know. Tony?
3 3s is equal to 1.
Yeah.
So if you
Yeah.
take the
Okay.
denominator.
Let's show you what Tony's trying to say. He's saying that 6 2/3 is nothing but 6 plus 2/3. And this 6 is understood to be over 1. So the LCD for this expression would be
3.
3. Therefore, we want to make each one of our denominators 3. We have to multiply the top first one by 3 over 3. That gives us 18. Second one is okay. Leave it alone. We now add these up. And that's what gave you the right to do what you did, Mike. Now, if you understand arithmetic, the algebra follows right from that. So let's take a look at some algebraic mixed numbers. And we want to convert these to single fractions. Let's start off with 2x minus 5 over 3x. We have an algebraic mixed number. And we'd like to convert this to a single fraction. Okay. Should be nice and easy. Jan? Nothing. Wong? What do you have?
11x over 3.
I didn't get that. He said 11x over 3. I didn't get that. BB, you get something?
6x squared minus 5. Over 3.
Right. 6x squared minus 5 over 3. How do we get it? Well, this is understood to be over 1. So now what we have to do is find the LCD. Jan, what's the LCD here? 3x. We want to make each one of our denominators 3x. What are we going to have to multiply this first denominator by in order to make it 3x? Therefore, we have to multiply the top by 3x. 3 times 2 is 6. X times x is x squared. Minus our second denominator. What are we going to have to do to that, Jan, in order to make it 3x? What are we going to have to do with that in order to make it 3x? Nothing. We don't do anything with the top either. There's our answer. Okay? Let's try this one. 2a minus 7 plus 3 over 4a. That's 2a minus 7 plus 3 over 4a. Okay, Wong, did you get something?
Minus 28 plus 3 over 4a.
Say again?
Minus 28 plus 3 over 4a.
Ah, I see what you did. It hurts a little bit. I know. You got minus 20a.
Yeah.
Did everybody see I got minus 20a? How come I do? Jan,
I have 6a squared minus 28 plus 3 over 4a.
you have 6a squared minus 28a plus 3 over 4a. I want to tell you, Jan, your algebra is fantastic. Your arithmetic is horrendous. Okay? Let's see where you made a mistake here. Jan, LCD for this expression.
Oh, really?
Yeah. Our LCD is 4a. Okay, Wong. I want to make each one of these denominators 4a. What we're going to have to multiply this first denominator by in order to make it 4a?
8a squared.
What is it? Okay. Yeah, you didn't say that. You know, his mistake is when he multiplied this by 4a, he multiplied the top, instead of getting 8a squared, he got 8a.
Right.
I knew that as soon as you said negative 28. Here we want to make both of these. We want to make this denominator 4a. We multiply that by 4a. We multiply the top by 4a. The numerator, well, this is already it. This is what we have. Okay. What's that?
Does not factor.
No. The ones you're going to have very shortly will be factorable after I go through these, because I'm making these up, and likelihood of being factorable is practically nil. Okay, let's try this one. Let's suppose we have a minus 3 over 2a plus 7. That's a minus 3 over 2a plus 7. Yeah, make that line all the way across. Yeah, the whole thing's over that, not just... Okay, Wong, one time. What do you get?
2a squared plus 4 over 2a plus 7.
This is not our day, Wong. Not our day. BB.
2a squared plus 7a minus 3 over 2a.
Very good. Very good. Here we go. Our LCD here is going to be 2a plus 7. Therefore, we want to make each one of our denominators the same as this LCD. We're going to have to multiply both numerator and denominator, the first term, by 2a plus 7. Second term already has it for a denominator. We don't do anything with that. We don't do anything with the numerator. And there, single fraction. We now clear these parentheses out. We have 2a squared. A times 7 is
7a.
7a. Minus 3 over 2a plus 7. One more. One more. Let's suppose we have 3x plus 2 minus 5 over x minus 4. I like that. Okay. Wong.
Again, okay. 3s squared minus 10s minus 13 over s minus 4.
Very good. The only thing there, Wong, is that that numerator is factorable.
Yeah.
Numerator was factorable in this problem. Let's take a look at this. Our LCD is x minus 4. We want each of our terms to have x minus 4 as the LCD, as the denominator. That means this first term, I'm going to have to multiply both numerator and denominator by x minus 4. Second term, again, I'm going to have to multiply each numerator and denominator by x minus 4. Third term, it already has x minus 4 for denominator. I don't do anything with that. I don't do anything with the numerator. And there is our mixed number as a single fraction. What that leaves us to do is to simplify the numerator. That means clear these parentheses, combine like terms, factor if possible. So we have 3x squared minus 12x plus 2x minus 8 minus 5. Combining like terms, we have 3x squared minus 10x minus 13. This was factorable. And there's the answer. Okay? There I got that. Okay. Now that you know how to change a mixed number to a single fraction. Let's go on. Let's suppose I have this problem. 6 2/3 over 2 1/2. 6 2/3 over 2 1/2. Here we have an arithmetic expression. We have a mixed number over a mixed number. This is called a complex fraction. A complex fraction is when you have a mixed number over a mixed number, or a fraction over a fraction, or any combinations of such. This is the way the problem appears in a book. Now, the question is, how do you interpret this problem? What's it saying to you? Mike, what's it saying to you?
Well, you have two whole numbers.
Yeah, but what's it saying? Read that to me.
6 2/3 over 2 1/2.
Okay, 6 or what else could he say? You're right, Tim. Be proud of that. 6 2/3 divided by 2 1/2. So our first step is to copy this down in workable form. This is 6 2/3 divided by 2 1/2. Okay, so now we have it in workable form. What are we going to do now? No.
Well,
No.
proper fraction.
Yeah, change these mixed numbers into equivalent fractions. You call them improper fractions. Nothing improper. Okay? So if I do that, I have 20/3 divided by 5/2. What are we going to do now?
Me upset.
Yeah, divide. Well, we know what divide means. It means invert. Multiply. Okay. We know how to multiply. That says 20 times 2 over 3 times 5. We now have to simplify it. Well, 20 is 4 times 5 times 2 over 3 times 5. The 5 over 5. Our answer is 8/3. 8/3. This is an arithmetic problem. You understand arithmetic? Algebra follows the same suit. So let's take a look at algebraic complex number. It's x plus 2 minus 10 over 2x plus 3 all over x minus 8 plus 30 over 2x plus 3. Yes. Back and forth, back and forth. What'd you get for the top one?
6x squared minus 2x.
How'd you get 6x squared?
Added
I didn't get 6x squared. I didn't get it.
squared plus 3x.
2x squared?
2x squared plus 3x
Yeah.
plus 4x.
Where's... Uh-huh. Yeah, they're both factorable. Do it correctly. Very good. What happened to this 30? Oh. Good, Michael. Good. Very good.